Okay, Nandi. So successfully 2 topics completed, thermodynamics and chemical kinetics, right? Next one. So in JL syllabus, colligative properties mentioned. In colligative properties, we have various methods to express concentration. Okay, so while we are discussing other topics also, that concept is required, various methods to express concentration. So from colligative properties, we will discuss that concept and various methods to express concentration. Okay, in the before that, some other concepts like atomic mass unit and atomic mass. And what is atomic mass? Some basic concepts I am giving. What is atomic mass? Atomic mass is the mass of one atom of an element. Atomic mass is the mass of one atom of an element. Always atom means it is a small particle or big particle. Small particle. It is a microscopic particle. Right? Atom is a small particle, right? Microscopic particle. So can we get directly absolute masses of atoms? No, we cannot get directly absolute masses of atoms since they are very, very small particles. So we can give relative masses only. We can give relative masses only by taking some reference. By taking some reference, we can give masses of atoms only. Okay, here atomic mass is the mass of one atom of an element. Atoms are small particles, microscopic particles. Their mass we cannot, their absolute masses we cannot calculate directly. So we can give their relative masses by taking some reference. That reference we take, that is C12 only. Carbon 12 we take as a reference. Since this is the stable isotope of carbon and its natural abundance is high and it has whole number mass. Carbon 12 has whole number mass. That's why this carbon 12 is preferred only. So with respect to carbon 12 mass, by taking reference, we can give the mass of other atoms. Okay. Now write the definition of atomic mass. What is the definition of atomic mass? Atomic mass, it is a number, right? It is a number. Whatever the basic material I shared you in our group, in that basic material also these definitions are there. And okay, right? It is a number that indicates, it is a number that indicates, it is a number that indicates how many times, it is a number that indicates how many times the mass of one atom of an element, the mass of one atom of an element, the mass of one atom of an element is heavier compared to 1/12th mass of one atom of, compared to 1/12th mass of one atom of carbon 12, compared to 1/12th mass of one atom of carbon 12. So compared to this mass, and compared to this mass, our atom mass is how many times more? Compared to this mass, our atom mass is how many times more? That is called as atomic mass of that atom. That is called as atomic mass of that atom. Here 1/12th mass of one atom of carbon 12, that we are taking as reference. Okay, compared to this weight, how many times the mass of this atom is heavier? That is called atomic mass. Okay, this is called as 1/12th mass of one atom of carbon 12 is called as atomic mass unit. Okay, what is atomic mass unit? Atomic mass unit, simply we indicate as AMU, atomic mass unit, or it is also called as unified mass. Atomic mass or unified mass. U, atomic mass or unified mass U. What is atomic mass unit? 1/12th mass of one atom of carbon 12 is called atomic mass unit, right? 1 by 12th mass of 1 by 12th mass of one atom of carbon 12 is called atomic mass unit. 1 by 12th mass of one atom of carbon 12, 1 by 12th mass of one atom of carbon 12 is called atomic mass unit. Okay, so if you see the actual mass of one atom of carbon 12, actual mass of one atom of carbon 12. Okay, what is the mass of one carbon 12 atom? What is the mass of one carbon 12 atom? If you see 1.9924 into 10 power minus 23 grams. 23 na antega 1.9924 into 10 power minus 23 grams. That is the mass of one atom of carbon 12. Now atomic mass unit. Atomic mass unit means what andi? 1 by 12th of this mass. 1 by 12th of this mass is called atomic mass unit. So that means 1.9924 into 10 power minus 23 by 12 grams. So if you simplify this, we will get 1.66 into 10 power minus 24 grams. 1.66 into 10 power minus 24 grams we will get. So one atomic mass unit is equal to how many grams? One atomic mass unit is equal to 1.66 into 10 power minus 24 grams, or in kgs it is 1.66 into 10 power minus 27 kgs. So compared to this mass, how many times the mass of one atom of an element is heavier? That is called atomic mass of that element. Okay, right? So therefore the formula for atomic mass is, so you remember atomic mass unit value, and it is useful somewhere while we are solving problems. What is atomic mass unit value? 1.66 into 10 power minus 24 grams, or in SI units it is 1.66 into 10 power minus 27 kgs. So atomic mass is nothing but mass of one atom of an element, mass of one atom of an element by what? 1 by 12th mass of one atom of carbon 12. 1 by 12th mass of one atom of carbon 12. So compared to this mass, this is how many times more? That is called its atomic mass. Otherwise, mass of one atom of an element by 1 by 12th mass of one atom of carbon 12 is called what? Atomic mass unit. Atomic mass unit. Or we can write like this. Atomic mass unit is nothing but 1.66 into 10 power minus 24 grams. In grams only. Right, this is the concept of atomic mass. Okay, so based on this scale, okay, if you measure atomic mass of hydrogen atom, it is observed that atomic mass of hydrogen atom is 1.008 atomic mass units, almost one atomic mass units. Okay, that means mass of one hydrogen atom is how many times more compared to 1 by 12th mass of one atom of carbon 12? 1.008 times more, and 1.008 times more compared to 1 by 12th mass of one atom of carbon 12. Okay, therefore what is the actual mass of one hydrogen atom in grams? Okay, actual mass of one hydrogen atom in grams is 1.008 into one atomic mass unit is equal to how many grams? 1.66 into 10 power minus 24 grams. This is the weight of how many hydrogen atoms? One hydrogen atom. That is the weight of one hydrogen atom. Similarly, if you see atomic mass of oxygen atom, how much? 16 atomic mass units. 16 atomic mass units, or 16 into 1.66 into 10 power minus 24 grams. This is the mass of one oxygen atom. So always if you express in atomic mass units, if you express mass in atomic mass units, that indicates one atom mass or more than one atom mass andi. Only one atom mass andi. If you express in atomic mass units, that indicates only one atom mass andi. Okay, right andi. This is atomic mass concept. Next one, gram atomic mass andi. Gram atomic mass. So this gram atomic mass is nothing but atomic mass expressed in grams andi, and this is the mass of Avogadro number of atoms andi. Okay, Avogadro number of atoms mass expressed in grams is called gram atomic mass. Okay, it is the Avogadro number of atoms mass. It is the Avogadro's number of atoms mass expressed in grams. It is the Avogadro number of atoms mass expressed in grams. Nothing but molar mass andi. Recently we are calling it as molar mass. Previously they called as gram atomic mass. Okay, Avogadro number of particles means how many moles andi? 1 mole. Avogadro number of atoms means how many moles andi? 1 mole. 1 mole of atoms mass, nothing but molar mass andi. Nothing but molar mass. Okay, it is the Avogadro number of atoms mass expressed in grams. For example, gram atomic mass of hydrogen, if you take gram atomic mass of hydrogen is equal to how many hydrogen atoms mass andi? Gram atomic mass means how many hydrogen atoms mass andi? Avogadro number of hydrogen atoms mass. Avogadro number of hydrogen atoms mass. Avogadro number means 6.02 into 10 power 23 number of hydrogen atoms we have to take. What is the weight of each hydrogen atom? What is the weight of each hydrogen atom in grams? 1.008 into 1.66 into 10 power minus 24 grams. So if you simplify, almost you will get 1 gram around, or 1.008 gram nearly. So therefore, what is the gram atomic mass of hydrogen andi? 1 gram. Okay, see the difference. 1 atomic mass unit means how many hydrogen atoms mass? 1 hydrogen atom mass. 1 gram means how many hydrogen atoms mass? Avogadro number of hydrogen atoms mass andi. Okay, see the difference andi. While we are studying quantum chemistry, we study in microscopic level or macroscopic level andi? Microscopic level. So we may study about one particle. So we need one particle mass. Whenever we need one particle mass, we have to write in atomic mass units andi. Okay. Next one, this is gram atomic mass. Okay, and similarly gram atomic mass of oxygen, what we get andi? Gram atomic mass of oxygen. Okay, how many oxygen atoms mass andi? Avogadro number of oxygen atoms mass. What is the mass of each oxygen atom? 16 into 1.66 into 10 power minus 24 grams. If you simplify this, nearly we will get 16 grams. So 16 atomic mass units is the mass of one oxygen atom, whereas 16 grams is the Avogadro number of oxygen atoms mass. Next one, molecular mass. Similarly, so molecular mass is nothing but molecular mass of a given substance is nothing but how many times it is heavier compared to 1/12th mass of one atom of carbon 12. Okay, atomic mass means what? Okay, how many times the mass of one atom of an element heavier compared to 1/12th mass of one atom of carbon 12, that is atomic mass. Similarly, molecular mass means how many times the mass of one molecule, of a substance, how many times the mass of one molecule of a substance heavier in compared to 1/12th mass of one atom of carbon 12, that is called molecular mass. So molecular mass formula is mass of what we get andi, one molecule, mass of one molecule of a substance, mass of one molecule of a substance by 1/12th mass of one atom of carbon 12, or we can write simply atomic mass unit. Or simply molecular mass is nothing but sum of atomic masses. Antena kada? Molecular mass is nothing but simply sum of atomic masses. Molecular mass is nothing but sum of atomic masses of atoms present in the molecule. Or molecular mass is nothing but simply sum of atomic masses of atoms present in the molecule. For example, molecular mass of H2O, if you take molecular mass of H2O, how many hydrogen atoms are there? 2 hydrogen atoms. Each hydrogen atomic mass is 1 atomic mass unit, nearly 1 atomic mass unit. And what about oxygen atomic mass? 16. So therefore what we will get? 18 atomic mass units. 18 atomic mass units. Or the mass of one H2O molecule is 18 times heavier compared to 1/12th mass of one atom of carbon 12. The mass of one molecule of H2O is 18 times heavier compared to 1/12th mass of one atom of carbon 12. Okay, 18 atomic mass units, like this we can calculate. 18 atomic mass units, the mass of how many H2O molecules? One H2O molecule. And lastly, similarly, gram molecular mass. Gram molecular mass. Gram molecular mass. Same, it is the Avogadro number of molecules mass. It is the Avogadro number of molecules mass expressed in grams. It is the Avogadro number of molecules mass expressed in grams. Right, it is the Avogadro number of molecules mass expressed in grams. It is the Avogadro number of molecules mass expressed in grams. Okay, it is the Avogadro number of molecules mass expressed in grams. Okay, Avogadro number of molecules means how many mole of molecules? 1 mole of molecules. So 1 mole of molecules mass, and simply 1 mole of molecules mass is called gram molecular mass. 1 mole of molecules mass is called gram molecular mass. Okay, for example, gram molecular mass of H2O. Gram molecular mass of H2O. Gram molecular mass of H2O. How many H2O molecules we have to take? Avogadro number of H2O molecules we have to take. 6.02 into 10 power 23. Each H2O molecule mass is 18 atomic mass units. If you convert into grams, one atomic mass unit is equal to 1.66 into 10 power minus 24 grams. So if you simplify, we will get 18 grams. If you simplify that, we will get 18 grams. So 18 atomic mass units is one H2O molecule mass, whereas 18 grams is Avogadro number of H2O molecules mass. Okay, this is the concept of atomic mass, gram atomic mass, molecular mass and gram molecular mass. Gram atomic mass and gram molecular mass is nothing but mass of 1 mole of atoms, 1 mole of molecules. Okay, right, and the next one, mole concept. And mole concept. Mole concept. What is mole? And 1 mole of substance means what? It possesses how many number of particles? Avogadro number of particles. Okay, so mole, 1 mole is nothing but it is the amount of substance that consists how many number of particles? Avogadro number of particles. Okay, how much amount of substance is required to contain Avogadro number of particles? That amount is called 1 mole. Okay, so write 1 mole. It is the amount of substance It is the amount of substance. It is the amount of substance. It is the amount of substance that contains. It is the amount of substance that contains Avogadro's number of particles. It is the amount of substance that contains Avogadro's number of particles. Okay, this Avogadro number also actually will get based on carbon 12 only. Okay, if you take carbon 12, okay, 1 mole of carbon 12 possesses 6.02 into 10 power 23 particles only. Based on that, this was defined. Okay, so whatever the number of particles present in carbon 12, so that is 6.02 into 10 power 23, that is called as Avogadro number. So to get same number of particles, what is the amount of substance required? That is called 1 mole. Okay, so you just remember, it is the amount of substance that contains Avogadro number of particles, that is 6.02 into 10 power 23. Whether is it depends on nature of substance or independent of nature of substance. Mole concept is independent of nature of substance. It is independent of nature of substance. That means it is independent of nature of substance. That means 1 mole of any substance contains 1 mole of any substance contains Avogadro number of particles. It is independent of nature of substance. That is 1 mole of any substance contains 1 mole of any substance contains Avogadro number of particles. 1 mole of any substance contains Avogadro number of particles. For example, I am saying 1 mole of hydrogen atoms means how many hydrogen atoms are there? Avogadro number of hydrogen atom. 1 mole of hydrogen atom means 6.02 into 10 power 23 number of hydrogen atoms. Next, 1 mole of H2O molecules I am saying. 1 mole of H2O molecules means how many H2O molecules are there? 6.02 into 10 power 23 number of H2O molecules. 1 mole of H2O molecules means Avogadro number of H2O molecules. For example, I am saying 1 mole of electrons means how many electrons are there? 6.023 into 10 power 23 number of electrons. So always 1 mole of a substance contains Avogadro number of particles, whatever may be the nature of substance. 1 mole of any substance contains Avogadro number of particles. Okay, how to calculate number of moles and formula is number of moles is equal to weight by gram atomic weight or gram molecular weight. Gram atomic weight or gram molecular weight. Otherwise, you can substitute molar mass also. Okay, 1 mole of particles mass and 1 mole of particles mass. Weight by molar mass or weight by gram atomic weight or weight by gram molecular weight. For atoms, gram atomic weight. For molecules, gram molecular weight. Weight by molar mass, general term. Okay, general term. Or if number of particles I am giving, how to calculate number of moles? Number of particles by Avogadro number. Number of particles by Avogadro number gives number of moles. Number of particles by Avogadro number gives number of moles. I am giving 6.02 into 10 power 23 particles means how many moles of particles? 1 mole of particles. I am giving 12.04 into 10 power 23 number of particles. The number of moles is 2. Okay. Next one. For example, I am giving volume in liters under STP or NTP conditions. I am giving volume in liters under STP or NTP conditions. Then how to calculate number of moles? Volume in liters by 1 mole of any gas under STP conditions occupies how much volume? 22.4 liters. Okay, a small difference between STP and NTP. Here we follow pressure 1 bar Here we follow pressure 1 atmosphere andi. 1 bar means how many atmospheres andi? 0.987 atmosphere. So here we get actually molar mass 22.7 liters andi. Here we get 22.4 liters, but difference is very small. In all the books they are giving only 22.4 liters only. So you follow 22.4 only. Okay. Here pressure is slightly small and smaller is the pressure, higher is the volume. So slightly here volume is more, slightly here volume is more, and 22.7 liters. Okay, anyhow in books they are giving in both the cases 22.4 only, most of the books. So you follow 22.4. Okay, so volume in liters by 22.4. Okay, if I am giving 44.8 liters of gas under NTP conditions, how many moles of gas? 2 moles of gas. Okay, if you substitute volume in liters or decimeter cube, 1 decimeter cube is equal to what? 1 liter. Next, volume in centimeter cube or ml. If I give volume in centimeter cube or ml, we have to divide with what? 22,400. 22,400. I am giving 22,400 ml of substance. 22,400 ml of substance. That means how much amount of substance? 1 mole of substance. 44,800 ml of substance I am giving under NTP conditions. 44,800 ml of substance I am giving under NTP conditions. How many moles of substance? 2 moles. Okay, so like this we can calculate number of moles. Number of moles is equal to weight by molar mass, or number of particles by Avogadro number, or volume in liters by 22.4, or volume in ml by 22,400 under NTP conditions. This is under NTP conditions. Okay, or weight by atomic weight, or weight by gram atomic weight, or weight by gram molecular weight we can follow. Okay. Okay, now we see some conceptual questions based on mole concept. Okay. Right. A piece of copper weighs 0.635 grams. 0.635 grams. Continuation. How many atoms of copper does it contain? How many atoms of copper does it contain? Okay, weight of copper I am giving 0.635 grams. Then how many atoms of copper are present? And the 0.01. Number of copper atoms? Right. Okay. So what is the number of moles of copper atoms present in it? Number of moles is equal to weight by molar mass. Okay. So weight is 0.635. What is the gram atomic weight of copper? Avogadro number of copper atoms mass? 63.5 grams. Gram atomic weight of copper is 63.5. That means what we are getting? 0.01. That is 10 power minus 2 moles we are getting. This is number of moles. But what is the question? Number of copper atoms. Number of copper atoms. Each 1 mole contains how many copper atoms? Avogadro number of copper atoms. 6.02 into 10 power 23 copper atoms. That means 6.02 into 10 power 21. So that is the number of copper atoms present in 0.635 grams of copper. Next one. Calculate the number of molecules. Calculate the number of molecules. Calculate the number of molecules in 11.2 liters of SO2, calculate the number of molecules in 11.2 liters of SO2 gas, in 11.2 liters of SO2 gas at NTP. Calculate the number of molecules in 11.2 liters of SO2 gas at NTP. How much? Right. 11.2 liters of SO2 under NTP condition. That means how many moles? And number of moles is equal to what? Volume in liters by 22.4. Volume given 11.2 by 22.4. That means how many moles of SO2 gas is present? Half mole of SO2 gas is present. But the question is number of moles or number of molecules? And number of molecules. So number of SO2 molecules. Number of SO2 molecules is 1 by 2 into 6.02 into 10 power 23. That is 3.01 into 10 power 23. 3.01 into 10 power 23. That is the number of SO2 molecules present in 11.2 liters of SO2 gas. Okay. Next, calculate the volume of 20 grams of hydrogen gas. Calculate the volume of 20 grams of hydrogen gas at NTP. Calculate the volume of 20 grams of hydrogen gas at NTP. That 112. How many moles? Number of moles is equal to what? Weight by gram molecular weight. Weight by gram molecular weight. Weight is given 20. What is the molecular weight of hydrogen? 2. That means how many moles? 10 moles. So number of moles is 10. What is the question? Volume occupied by 20 grams of hydrogen gas under NTP conditions. So what is the volume? Volume of hydrogen gas. 10 into 1 mole of each gas occupies how many liters under NTP conditions? 22.4 liters. Therefore we get 224 liters. So 20 grams of hydrogen gas occupies 224 liters under NTP conditions. Okay, first we have to calculate number of moles. Weight by gram molecular weight. 20 by molecular weight of H2 is 2. So 10. Next one. Calculate the number of atoms present in. Calculate the number of atoms. Calculate the number of atoms present in. Calculate the number of atoms present in 5.6 liters. 5.6 liters of A. 5.6 liters of A. First one. Calculate the number of atoms present in 5.6 liters of A. Monoatomic and the second one diatomic gas. Monoatomic and diatomic gas at NTP. What is the number of atoms present? First calculate the moles of gas. First calculate the number of moles of gas. From that you calculate number of atoms. First you calculate the number of moles of gas. What is the number of moles of gas? Number of moles is equal to under NTP conditions volume in liters by 22.4. That means how many moles we are getting? 1 by 4 moles we are getting. In each case 5.6 liters only given. So what about the number of moles of gas? 1 by 4 moles of gas. In the first case we are getting 1 by 4 moles of monoatomic gas. 1 by 4 moles of monoatomic gas. Okay, 5.6 liters is nothing but 5.6 liters is nothing but what? 1 by 4 moles of monoatomic gas. That means what about number of atoms only? 1 by 4 into each mole contains how many atoms only? Okay, Avogadro number of atoms, 6.02 into 10 power 23. So nearly we get 6 by 4, 1.5 into 10 power 23. That is the number of atoms present. Okay, 1 by 4 moles of monoatomic gas we are getting. Each 1 mole of gas possesses Avogadro number of atoms. So then 1 by 4 moles possess 1.5 into 10 power 23 number of atoms. What about for diatomic gas? 5.6 liters contains how many moles of gas? 5.6 liters means how many moles? 1 by 4 moles. So now in this case 1 by 4 moles of which gas is present? Diatomic gas. For example, monoatomic gas means Xn. Diatomic gas means X2. Here number of atoms means X. Here again number of atoms X. Okay, in each diatomic molecule how many X atoms are there? 2 X atoms are there. So we have to multiply with 2 only. Okay, 1 by 4 into 6.02 into 10 power 23. Okay, this is the number of X2 molecules we are getting. This is the number of what? X2 molecules we are getting. But what is the question? Number of X atoms. So that means we have to multiply with 2. Okay, otherwise you write one more point and number of X2 molecules is equal to 1 by 4 into 6.02 into 10 power 23. After that you write number of X atoms. We have to multiply with 2. So 2 1s are 2 2s are. So we get 3.01 into 10 power 23. So that is the number of X atoms. Next one. How many atoms are there? How many atoms are there? How many atoms are there? How many atoms are there in 100 atomic mass units of helium? How many atoms are there in 100 atomic mass units of helium? How many atoms are there? What is the mass of one helium? Mass of one helium atom. What is the molar mass of helium? Gram atomic weight of helium? 4 grams. Okay, now 4 grams is the Avogadro number of helium atoms mass. What is the mass of one helium atom? What is the difference? For Avogadro number of atoms we will get in grams. For one atom we will get in atomic mass units. For one atom we will get in atomic mass units. For Avogadro number we will get in grams. So 4 grams is the gram atomic weight of helium. 4 atomic mass units is the mass of one helium atom. Mass of one helium atom. So in 4 atomic mass units, how many helium atoms are present? One helium atom is present. Then in 100 atomic mass units, how many helium atoms are present? Okay, number of helium atoms. 25 kadandi. 100 by 4. So that is 25. Okay, each helium atom mass is 4 atomic mass units. 25 helium atoms mass is 100 atomic mass units. Okay. Next one. Calculate the total number of electrons. Calculate the total number of electrons. Calculate the total number of electrons present in. Calculate the total number of electrons present in. total number of electrons present in 1.6 grams of methane. 1.6 grams of methane. Okay, how many electrons are present in 1.6 grams of ethane? First you tell me, in each molecule of ethane, how many electrons are present? 10 electrons. In carbon 6, 4 hydrogen atoms, 4. 10 electrons are present in each methane molecule. So now you calculate what is the total number of methane molecules. So first you calculate number of moles, from that you can get number of molecules. After getting number of molecules, if you multiply with 10, you will get total number of electrons. Right. First calculate number of moles and then number of molecules. How many moles? 0.1 moles, right. Number of moles of methane is equal to weight by gram molecular weight. Weight by molecular weight in grams. Okay, 1.6 by molecular weight is 16. So 0.1 moles and 0.1 moles. That means number of CH4 molecules. Number of CH4 molecules is equal to 0.1 means 10 power minus 1, and each 1 mole possesses Avogadro number of molecules. So 6.02 into 10 power 23. So that means we get 6.02 into 10 power 23. This is the number of methane molecules. That is the number of methane molecules. Each methane possesses how many electrons? 10 electrons. Each methane possesses 10 electrons. 6 from carbon, 4 from 4 hydrogen atoms. So therefore number of electrons. Total number of electrons present is, number of molecules are 6.02 into 10 power 22. Number of electrons in each molecule is 10. So we get 6.02 into 10 power 23. Number of electrons presented. 6.02 into 10 power 23. Okay, next one. What will be the volume occupied? What will be the volume occupied? What will be the volume occupied? What will be the volume occupied by 1 mole of atoms? What will be the volume occupied by 1 mole of atoms? 1 mole of atoms of a first one, monoatomic gas, second one, diatomic gas at NTP. Once again, what will be the volume occupied by 1 mole of atoms of a monoatomic gas, diatomic gas at NTP? 1 mole of any gas occupies how much volume under NTP conditions? 22.4 liters. You write that point. 1 mole of any gas, whether it may be monoatomic or diatomic or polyatomic, X or X2, whatever it may be. 1 mole of any gas, okay, or X3, ozone if you take for example. 1 mole of any gas occupies 1 mole of any gas occupies 22.4 liters under NTP conditions. 1 mole of any gas occupies 22.4 liters under NTP conditions. And now monoatomic gas is given. Monoatomic gas means X. Okay, 1 mole of X atoms occupies how much volume under NTP conditions? 22.4 liters only, right? So 1 mole of monoatomic gas and 1 mole of atoms and 1 mole of atoms in monoatomic gas. what is the question and 1 mole of atoms. 1 mole of atoms in monoatomic gas occupies how much volume andi? Same kadandi, 1 mole of atoms in monoatomic gas. Okay, in 1 mole of monoatomic gas, how many atoms are present? 1 mole of atoms present. In 1 mole of monoatomic gas, how many atoms are present? 1 mole of atoms present. Okay, so 1 mole of atoms in monoatomic gas occupies 22.4 liters under NTP conditions. Now, if you take diatomic gas, 1 mole of atoms in diatomic gas. Diatomic gas means X2. In diatomic gas, how many moles of atoms present? In 1 mole of diatomic gas, how many moles of atoms present? 2 moles of atoms present. That means 2 moles of atoms occupies 22.4 liters. Then 1 mole of atoms occupies 11.2 liters. Okay, then? In 1 mole of diatomic gas, how many moles of atoms are there? 2 moles of atoms are present. But the question is what? 1 mole of atoms. 1 mole of atoms occupies how much volume? 11.2 liters. 1 mole of atoms in diatomic gas occupies 11.2 liters. 11.2 liters. Okay, and since 1 mole of X2 gas is equal to how many moles of atoms? 2 moles of X atoms. 1 mole of X2 gas is nothing but 2 moles of X atoms. Okay, 1 mole of X2 gas occupies 22.4 liters. That means 2 moles of X atoms occupies 22.4 liters. Then 1 mole of X atoms occupies 11.2 liters. Okay. If you take triatomic gas, what do we get? 22.4 by 3. 1 mole of atoms in triatomic gas occupies how much volume? 22.4 by 3 liters under NTP conditions. Next one, find the charge of 27 grams of Al3 plus ions. Find the charge of 27 grams of Al3 plus ions in coulombs. Find the charge of 27 grams of Al3 plus ions in coulombs. Okay. First, how many moles of aluminum we will get? 27 by, what is the gram atomic weight of aluminum? 27, na? Okay. 27 grams of aluminum means how many moles of aluminum? 1 mole of aluminum. 27 grams of aluminum means 1 mole of aluminum. So that means how many moles of aluminum 3 plus ions we have? 1 mole of Al3 plus ions we have. 1 mole of Al3 plus ions we have. Now we want to calculate what? Charge in coulombs. Okay, 1 mole of aluminum 3 plus ions means how many aluminum 3 plus ions? 6.02 into 10 power 23 aluminum ions we have. 6.023 into 10 power 23 aluminum ions we have. On each aluminum ion, how many units of positive charge is present? 3 units of positive charge is present into 3. Okay, but the question is we have to give charge in coulombs. Okay, each proton, okay, each positive charge is equal to how many coulombs? Okay, the charge on proton is equal to, in coulombs, the charge on proton is equal to 1.602 into 10 power minus 19 coulombs. Charge on electron also same, 1.602 into 10 power minus 19 coulombs. Okay, 1.602 into 10 power minus 19 coulombs. Okay, Nandi, how many moles of aluminum ions we have? 1 mole of aluminum ions we have. Okay, on each aluminum, how many units of positive charge is there? 3 units of positive charge is there. Okay, the charge on each proton is given by 1.602 into 10 power minus 19 coulombs. Okay, you may simplify that. You will get 2.894 into 10 power 5 coulombs. 2.894 into 10 power 5 coulombs. Okay. Last question, right? Equal masses of oxygen, comma, hydrogen, equal masses of oxygen, comma, hydrogen and methane, equal masses of oxygen, comma, hydrogen and methane are taken in a container, in identical conditions, Find the ratio of the volumes of the gases. Find the ratio of the volumes of the gases. Find the ratio of the volumes of the gases. Okay, all those we are taking in equal masses. What about the ratio of their volumes? And ratio of the volumes of O2, H2 and CH4. According to Avogadro's law, volume is directly proportional to what? And number of moles. So weights are equal weights given, molar masses are known to us. So from that you may calculate number of moles. Okay, we know according to Avogadro's law, volume is directly proportional to number of moles. So that means the ratio of volume of O2 to H2 to CH4 is nothing but the ratio of number of moles of O2, H2 and CH4. V is directly proportional to N. So the ratio of volumes is nothing but ratio of number of moles. Number of moles means weight by gram molecular weight. Weight by gram molecular weight. What is the weight of all these three? And same given. Same, for example, X. The weight of all these three same. That means I am taking X. Okay. What about their molar masses? And what is the molar mass of oxygen? 32. Hydrogen 2. 16. Okay. X gets cancelled. So if you multiply with the 32, what we get? And if you multiply with 32, get 32 gets cancelled here, 16 here, 2. So the ratio of the volumes is 1:16:2 only. Okay, if you take equal masses of oxygen gas, hydrogen gas and methane gas, okay, under identical conditions, this is the ratio of their volumes. Okay, 1:16:2. Okay, this is the concept of mole and some questions based on mole concept. So in the next class we will discuss various methods to express concentration. From that you are getting direct questions also in JL, DL. Okay, so they are giving some direct questions from various methods to express concentration also. Okay, that we will discuss evening session. Now you have organic class. Okay, evening timings are what? 5 to 8. Okay, if any changes I will share in our group. Okay, right. Thank you.